do that. And okay, so we're good. Yo, when we were here in class yesterday, this was a problem that I hadn't yet done, so I want to go ahead and go through this one. Um, one of the reasons why I like this problem is that for the purpose of the test, okay, these types of equations, what we have right here, y'all, this is what we call a linear equation. I'm going to get into a little bit more of that today. But this is more the types of questions that I remember seeing on the test, okay? So it says, look, the cost in dollars Y, so let me get rid of this red box just so we can see everything. Okay, so the cost, y'all, is referring to the letter Y, okay, of producing X computer desks. So Y talks about how much things are going to cost. X tells me how many computer desks we're making, okay? And they give me this equation, Y equals 80X plus 5,000. And what they want us to do here is they want us to fill in the table. Okay, when X equals 100, we want to know what's going to be my number for Y. Okay, so this is what I'm going to do. I'm going to write out the equation that we have. Y equals 80X plus 5,000. Okay, for this part, y'all, I'm going to call this part A. They're asking me, can we plug in 100 for the number X? Okay, so 80 times 100, 8,000. 8,000 plus 5,000, that's going to be 13,000. Okay. Boom. There's my answer for part A. Okay. Y'all, I'm going to call this part B. For part B, they're asking me, can we come back to that same equation, but where the X used to be, can we put the number 200? Okay. So y'all, 80 times 200 is going to be 16,000. 16,000 plus 5,000 is 21,000. So, whoa. Okay. And then I have part C, y'all. So let's do part C. Let's call this part C. And now X is equal to 300, right? So look, we got 80 times 300 plus 5,000. Okay. And this is going to be, let's see, 8 times 3, 24. 1, 2, 3. 1, 2, 3. Okay, plus 5,000. So 24,000 plus 5,000, 29,000. Okay. So let me do this. Let me just kind of zoom out a little bit so we can see everything. Let's see, right here, y'all, I'm going to write 29,000. Okay. So let's think about what this tells me. Okay. Y'all, what this tells me right here, let me just kind of clean up some of those lines there. Okay. This tells me if we make 100 desks, it's going to cost us $13,000 to make those 100 desks, okay? If we make 200 desks, it's going to cost us $21,000 to make those 200 desks. And if we make 300 desks, y'all, it's going to cost us $29,000 to make those 300 desks, okay? So this equation tells me how much money we're going to spend to make a certain number of desks, okay? Now, y'all, I'm going to look at part B. I know there's another part B, but this part B right here. Okay. So it says find the number of computer desks that can be produced for 8,600. Okay. So look, y'all, we're looking for the number of desks. Okay. And they're telling me that we have 8,600 to spend. And look what it says right here. They gave us a hint. Find X when Y equals 8,600. So y'all, the equation that we had was this equation right here, right? And they're telling me we want to find the letter X when the number Y is 8,600. So y'all, where the letter Y used to be, we're going to put in 8,600. Okay. And now we're going to try to solve for the letter X. So the first thing I'm going to do, y'all, I'm going to get rid of this 5,000 by subtracting it, right? So let's go like this. Okay. 8,600 minus 5,000 should be 3,600. Okay, equals 80x. And then the last thing we're going to do, y'all, we're going to go ahead and divide everything by 80. Okay, so let's go like that. Let me grab my calculator here. Okay, I'm going to just make this a basic calculator. Okay, and we had 3,600 divided by 80, and I'm coming up with 45. Okay, so remember, y'all, what does this stand for? This is the number of desks. Okay, Now, before I go on, y'all, I want to mention something here. In this problem, we had $8,600 to spend, and we wanted to know how many desks could we make, and we came up with 45. Okay, so to kind of just put everything together, y'all, when I did the first part of this question, and I'm just going to look at the part A that we did right here. Okay, so when we did this part, remember what this said? If we were going to make 100 desks, it was going to cost us $13,000, right? Well, y'all, now we have less money. We only have 8,600. So if 100 desks cost $13,000, then when I have $8,600, the number of desks I should make, y'all, should be less than 100. And we came up with 45, right? So again, y'all, that's kind of the idea, is to kind of make, kind of get this idea of, does my answer make sense? Well, yeah, it should make sense, right? If I have less money, I should be able to make less desks, right? Okay, y'all, I'm going to scroll down a little bit further, and we're going to talk a little bit about intercepts, y'all. The intercept stuff I'm going to talk about. I'm going to talk about vertical lines, horizontal lines a little bit too, but I may not do necessarily every single problem. Again, I want to make sure we can get through everything today, y'all. Okay, so y'all, when we're talking about intercepts, we have two types of intercepts. The first one I'm going to talk about is something that we call the x-intercept. Okay, y'all, the x-intercept is going to be a point, and it's going to be a point along the x-axis. So here's my x-axis right here. I am looking, y'all, for this point right there. So if I were to think about what are the coordinates of the point, y'all remember when we're plotting points, we always start at the middle, and then we either go left to right, and then the second number tells me how I'm going to go up or down. So from the middle, we went to -4. And then since we didn't go up and since we didn't go down, y'all, that number is going to be 0. So my x-intercept is the point -4 and 0. Okay. Y'all, we have something else that we call the y-intercept. Okay. Now, the y-intercept, y'all, is where we hit the y-axis. Okay. So this line here, y'all, is my y-axis. Okay. So I'm looking for that point. Okay. So y'all, again, just like we plot a point, we always start here in the middle, right? And remember, the first number tells me how I'm going to go to the left, and the second number tells me how I'm going to go to the right. Or either the left or the right, the second number tells me up or down, okay? So let's see, we did not go to the left, and we did not go to the right, so my first number was 0, and then we went up to 3. So my y-intercept, y'all, is the point 0.03, okay? So y'all, a couple of things I want us to notice. In the x-intercept, y'all, the y number is going to be 0. And in the y-intercept, y'all, the x number is going to be 0. Okay. So in the x-intercept, we're trying to figure out what that number is going to be. And in the y-intercept, we're trying to figure out what that number is going to be because we already know that the other numbers are going to be 0. Okay. Let's see if we can do another one like that, y'all. Let's take a look at this one. Okay. Y'all, I'm going to do the same thing that we did before. I'm going to look for first my x-intercept. Again, y'all, here's my x-axis, okay? So look, I'm just going to draw a line right through here. That lets me know that's my x-axis. Where does my graph hit that line? Y'all, it actually hits it at 2 points, right? At both those points, okay? So look, we're going to have 2 of them. This point here, y'all, -2, 0, right? And this point here, +2, 0. So those are my x-intercepts, right? Remember we said in the x-intercept, y'all, the y number is always going to be 0, right? Okay. Now let's see if we can find the y-intercept. Okay. Y'all, the y-intercept is going to be that line. So y'all, here I'm looking for that point, right? So the coordinates of that point, y'all, are 0 and -2, right? Because we said in the y-intercept, the x number was always going to be 0, and we were going to try to find y, okay? Okay, y'all, I'm going to scroll down a little bit more, okay? And let's take a look at this one. Let's see if we can find our x-intercepts. Okay. Y'all, for my x-intercepts, it looks like we have 3 of them, right? So look, I'm going to go 1, 2, 3. I'm going to give you a hint too, y'all. The y number on all of them is going to be 0. So this one here, -2. This one here, +1. This one here, +3, right? So we got 3 x-intercepts, okay? Let's see if we can find our y-intercept, okay? So y'all remember, here's my y-axis. So that's the point that I'm looking for. I gave you a hint. First number is always 0. This number here, y'all, is 3, okay? And that's how we find those x-intercepts and those y-intercepts, okay? All right, let me scroll down a little bit further. Y'all, I'm going to skip this one. It's pretty much the same, okay? But I want to do these problems here because, y'all, so right now I'm teaching the Math 100 class, and we were going through this material here. And when we draw lines, there's a couple of ways we can go about doing them. And one of them is going to tell me we want to graph the line by plotting the intercepts, okay? Y'all, I'm going to scroll back to what we were doing right now. Remember when we did our intercepts? Y'all, when we were finding the x-intercept, remember the y number was always 0? And when we were finding the y-intercept, remember the x number was 0? That's what this table here is telling me to do, y'all. Okay, so we're going to make a table, y'all, and we're going to find a couple of points. I'm going to call this point A, and I'm going to call this point B. Okay, and we're going to go through the process and see if we can't figure this out. So, y'all, look, in part A, they're telling me the x number is 0. We want to know, hey, what's the y number going to be? Okay, so, y'all, I'm going to take a look at this equation that I got right here. I'm going to write it as -x plus 2y equals 6, okay? Where the letter x used to be, y'all, I'm going to write the number 0. Okay? And I'm going to solve for y. All right, let's take a look. Well, the opposite of 0, that's still 0. Okay? 0 plus 2y, and that's still 2y, right? Because if I have 2y and I add nothing to it, I still got 2y. And then my last step, y'all, I'm going to divide everything by 2. And I'm coming up with a y equals 3. Okay. So y'all, right here, I'm going to write in the number 3. Okay. Y'all, I'm going to repeat this process over here, and I'm going to do my part B. Now, in my part B, I don't know what the letter x is, but I do know that the letter y happens to be 0. Okay. So just like I did before, I'm going to take this equation right here, -x plus 2y equals 6. And where the y used to be, y'all, I'm going to plug in the number 0. Okay. All right, so here, y'all, I can think about this -x. If it helps me, I can think about it as a -1x, okay? Look, 2 times 0, still 0. Okay. Y'all, when we add 0 to something, it doesn't change what we had, right? And now I'm going to go ahead and divide everything by a -1. And 6 divided by -1, y'all, is just a -6. Okay. So right here, y'all, I'm going to put a -6. All right, y'all, now what I want us to do, I want us to plot those points. So look, the first point, y'all, is the point 0 and 3. That means when x is 0, so I'm not going to the left and I'm not going to the right, I'm going to go to y equals 3, so I'm going to go up to 3. Okay. In the second point, y'all, -6, 0, I'm going to move to the left 6 bases. Well, look, if this one here, sorry, okay, if this one here is -5, this one's got to be -6. And then since my second number is 0, y'all, I'm just going to stay right there. And y'all, we're going to go like this. And there's my line, right? And again, if I were to think about, hey, what are the coordinates of that point? That's -6 and 0, right? And if I were to think about, hey, what are the coordinates of that point? That's the point 0 and 3. And look, that's where those points are right there, right? But we were able to find those intercepts, right? We were able to draw the line and put those points, again, where it hits the x-axis and where it hits the y-axis, okay? Every single time I'm going to do these types of problems, y'all, I'm always going to make that table right there, okay? Anytime it tells me graph by plotting the intercepts, the key word here, y'all, intercepts, I'm going to make that table, okay? Y'all, there's another one. almost identical. Okay, real similar to this. The first thing I'm going to do right here, y'all, I'm going to make my little table. Okay, so I'm going to put a 0 here, and I'm going to put a 0 there. Okay, and we're going to go through the process and see if we can't figure this thing out. Y'all, I'm going to call this my part A, and I call this my part B. Okay, so look, y'all, in part A, I know that the letter X is 0, excuse me, but I don't have a number for the letter Y. Okay, y'all, I'm going to take the equation that I have here. X minus 2y is equal to 4. And where I used to have the letter X, y'all, I'm going to put the number 0. So 0 minus 2y equals 4. Well, y'all, 0 minus 2y is still a minus 2y, right? And then we can go ahead and divide everything by a minus 2. And since I'm dividing, y'all, a positive divided by a negative is a negative, and that's the negative 2, right? So, y'all, right here, I'm going to write it in red so it's a little bit easier to see. Boom, negative 2. Okay. All right, y'all, I'm going to come back over here, and I'm going to do my part B. Now, in part B, I don't know what the letter X is because we got a little blank there, but we do know that the letter Y happens to be 0. Again, y'all, I'm going to come back to the same equation that I got here. X minus 2 times 0 is equal to 4. Okay. Now, right here, y'all, 2 times 0, that's still 0, right? And X minus 0, that's still X. So, y'all, we got an X equals 4. So, right here, y'all, boom, I'm going to put the number 4. Okay. Now, let's go ahead and draw this line and see if we can't figure it out. So, look, y'all, here's my first point, 0 and negative 2. Remember, the first number tells me how do I go to the left and how do I go to the right. Since it's 0, I'm not moving to the left or the right, but I am going to come down here, y'all, to a minus 2. Okay. My second point, y'all, is the point 4 and 0. So the first number tells me, hey, look, let's move to the right 4. Since the second number is 0, y'all, I'm going to stop right there. Okay. Y'all, I'm going to draw my line. And again, if I think about it, hey, look, the coordinates of that point, 0, negative 2. And hey, the coordinates of that point are 4 and 0, right? And we were able to find those points just from looking at the equation and plugging in some zeros where they needed to be plugged in, okay? So again, y'all, when you're taking your test, the idea here, y'all, the idea here is, I'm just gonna write it down here, y'all. If you see the word intercepts, okay, and they give you an equation, that's what you're gonna do. You're going to fill out that table, okay? Just like we did right here. And we're just going to kind of, plug the numbers in and chug along. But if you see the word like, hey, graph this by finding the intercepts, this is exactly what we're going to do here, okay? All right. Y'all, horizontal and vertical lines. So one thing is when we talk about lines, y'all, horizontal lines, if you think about it this way, like if we said, hey, look, on Friday, let's go to, after you take your test, if you take it tomorrow, I don't know when you're taking it, but if you take your test and you pass, right, you're all excited, ooh, I did good, let's go celebrate at the beach, we're going to Louis' backyard. If you're looking at the horizon, y'all, the horizon goes left and right. So horizontal lines, y'all, look like that. They just move left and right. There's no like going up or going down. It's just strictly left and right. How do I know we have a horizontal line? When I look at the equation, y'all, the only letter that I see is the letter Y. So if it says, can we graph the line Y equals 5? Y'all, look, here's my Y-axis. Here's the point when Y equals 5. But we are trying to draw the line. There's our line, okay? This right here, y'all, is the equation of the line Y equals 5, okay? That's what the line looks like. It's a line because it's a horizontal line, and it's a line crossing at Y equals 5, okay? Now, y'all, the next thing we have are, what about vertical lines? Okay, so y'all, if horizontal lines go left and right, vertical lines, strictly up and down, okay? How do I know we have a vertical line? When I look at my equation, y'all, the only letter that I see is the letter X, okay? So if all I see is the letter X, y'all, what we're going to do is we're going to say, okay, look, when does X equal -1? Here's my x-axis. X equals -1 right here. But again, since we're drawing the line, boom, that's what my line's going to look like. Okay. So vertical lines are in the form x equals, and horizontal lines, y'all, are in the form y equals. Okay. So I'm going to scroll down to this next part here, and it says, can we find the equation of this line? So the first thing I want you to notice, this here is a vertical line. Okay. Y'all, vertical lines are always in the form x equals some number. Okay. Well, where is it hitting the x-axis? Oh, at 3. There it is. There's the equation. We already had the graph. We were just trying to see, can we go backwards? Can we write the equation? Yeah, it is. It's x equals 3. Okay. And then for this one, y'all, we're still doing the same thing. Okay. So the first thing I noticed about this line, y'all, this is a horizontal line, right? Because that line goes strictly left and right. Now remember, y'all, horizontal lines are always in the form y equals some number. Here's my y-axis. Where does it hit it at? Oh, it hits it at 3. Okay. So it's just going to be the equation. It's just y equals 3. So for these last two problems, y'all, we were just going backwards. Okay. We had the graph. How would we write the equation? All right. Okie dokie. Let me scroll down a little bit further. Okay. Y'all, we're going to talk now about the slope of a line. Okay. So, y'all, the slope, let me just kind of give you some information here. The slope, y'all, is what we call a rate of change. Okay. Now, y'all, we actually talk about slopes pretty much in day-to-day life. Okay. So let me give you a typical example of what would be a slope. If you work and you get paid by the hourly rate, so if you make $17 an hour, then that 17 would be your rate, right? That's the rate at which you get paid. If you come home one afternoon and you find out that, hey, there's a leak under the sink and you got to call a plumber, and the plumber says, yeah, I can go out there. I just want to let you know I charge $60 an hour. That $60, that is a rate. Okay. I don't know if y'all remember this or not. I don't know. Depends on how old you are. But back in the day when we first had cell phones, right? And we had phones like this, right? But they were like the big Zach Morris type phones. And you'd have to, you're going to make a call. They would charge you per minute, right? So you're paying 17 cents a minute or that kind of thing. That's a rate. Okay. So y'all, when we talk about slopes, we talk about it as a rate of change. And y'all, we usually describe this as either the rise over the run, or sometimes we call it the fall over the run. Okay. And I'm going to explain what's the difference between the two. Now, y'all, right here it says, look, we have 2 points, x1, y1, x2, y2. Y'all, the little ones and the little twos are just because this is the first point and this is the second point. Okay. So y'all, right here, what I'm going to do is I'm going to say, look, this is my first point. So I'm going to call this my x1 and my y1. This is my second point. I'm going to call that my x2 and my y2. And y'all, what we're going to do is we're going to use the formula right here to find the slope of our line. So y'all, I'm going to write down this formula, okay? And I'm going to start plugging my numbers in.
Okay, so the first part of the formula says,
what is my number y2? Look, y'all, my number y2 is the number -1. Then we have a minus sign, so I'm going to put a minus sign. My number y1. Y'all, my number y1 is the number 3. Okay. Then we have x2. Well, my number x2, y'all, is the number 4 minus my number x1. Y'all, x1 is the number -2. Okay. So right here, y'all, I'm going to say -1 minus 3. Remember, if I owed you $1 and I borrowed 3 more, hey, I owe you 4, right? Y'all, on the bottom, minus and minus is going to become plus. That's going to give me a 6. Y'all, we can make these numbers a little bit smaller. We can divide them both by 2. So -4 divided by 2 is a -2. 6 divided by 2 is a 3. Here is my slope, okay? Y'all, I'm going to show you what does the slope tell me in regards to the line, okay? So y'all, in addition to finding the slope right here, the other thing we needed to do is we needed to draw the line, Okay, so let's see if we can do that. Y'all, the first point here, negative 2, 3. Okay, just so I can think about where is that going to be? That's going to say go to the left 2 and then go up to 3. Okay. And then the point 4, negative 1 is going to say let's go to the right 4 and then we're going to go down to 1. Now, y'all, I'm going to try to do my best to draw this line as straight as I can. Not too bad. Okay. So here's my line. Okay. Now, y'all, when we were talking about the slope, I told you we're either going to think about this as the rise over the run or the fall over a run. Y'all, because this number was a negative 2, I'm going to think about that, the fall over the run. Okay, let's see what this is going to tell me. Y'all, all the slope is telling me is how do I move from one point to another, okay? So from this point right here, y'all, I'm going to fall 2 spaces. Look, 1, 2. And then I'm going to run to the right 3. 1, 2, 3. Hey, look, there's another point in my line. I'm going to do that again, y'all. I'm going to fall 2. 1, 2. 1, 2, 3. Okay. And y'all, I can keep doing that. 1, 2. 1, 2, 3. And all we're doing, y'all, is we're counting how many steps down, how many to the right, how many steps down, how many to the right, how many steps down, how many steps to the right. Okay. Now, y'all, we called this the fall because that number was negative. Okay. Y'all, the way I read a line is the same way that we read a sentence. Okay. Sorry. When we read this sentence right here, y'all, we go from the left to the right like that, right? From the left to the right. Okay, y'all, if I go here, y'all, from the left to the right, I would say this purple line, y'all, if I'm going from the left to the right, that line is going down, right? Okay, it's going down, y'all, because our slope had a negative number in it, all right? So if my slope has a negative number, my line's got to go down, okay? Now, let's do another one, very similar, okay? Almost the same. Same idea here, y'all. First thing I'm going to do, I'm going to write down my formula. M equals y2 minus y1 all over an x2 minus x1. That's my formula, okay? Y'all, right here, I'm going to call this my x1 and my y1. I'm going to call that guy my x2 and my y2, okay? And let's take a look-see at what we got here. Y'all, my number y2 is the number 5. Minus my number y1 is the number 1. Okay? My x2, y'all, is the number 3. Minus my x1 is the number negative 2. Okay. Y'all, just real quickly, I want to mention something. Why did I call this guy like my x2, y2? Remember, y'all, every point is always in the form x and y. Why did I call it x2, y2? Because this was the first point and that was the second. Okay. But I'm putting the x's in the first one and the y's in the second one because that's how we write our points. Okay. Just want to remind everybody of that. Y'all, let's take a look upstairs. 5 minus 1, that's 4. Down here, y'all, minus and minus make it plus. So 3 plus 2 is 5. Okay, so y'all, here, I don't have a negative in my slope, right? So this is what we're going to call, y'all, the rise over the run, okay? Y'all, I'm going to do something very similar. I'm going to go ahead and plot these same points that we had here, okay? So let's see, negative 2 and 1 means go to the left 2 and up to 1 right there. And then the point 3, 5, y'all, says let's go to the right 3 and let's go up all the way to 5. And again, y'all, I'm going to try to do my best to draw this line as straight as I can. Not too bad. Okay, now the rise over the run, y'all, means from this point right here, y'all, I'm going to go up 4. So look, I'm going to count 1, 2, 3, 4. Now I'm going to move to the right 5. 1, 2, 3, 4, 5. Boom. There's the point of my line. Okay. Y'all, I could do that again. 1, 2, 3, 4. Right 5. 1, 2, 3, 4, 5. Boom. There's another one, right? All it's doing, y'all, is counting my steps. Going up 4, going to the right 5. Going up 4, going to the right 5. Now, y'all, like I told you before, how do we read a line? We read a line, y'all, the same way we read a sentence. We go from the left to the right. Y'all, if I go from the left to the right and I follow my blue line right here, I would say that this line, y'all, is going up, right? It's going up. Y'all, it's going up because my slope here is a positive number, okay? So we're able to kind of figure out a couple of things. Y'all, if my line is going down, I should have a negative slope. If my line is going up, I should have a positive slope, okay? All right, let me scroll down a little bit further, okay? Y'all, what I want us to do, I want us to see if we can find the slope of these lines, okay? So y'all, remember, it's either going to be the rise or the fall all over the run. Okay, first thing, y'all, I'm going to notice my line, y'all, is going down, right? Again, from the left to the right, y'all, that line goes down. Boom. So in this case, y'all, it's going to be a fall, okay? Because it's a fall, y'all, that number is going to be negative, okay? Now, let's think about this for a minute, y'all. Here is a pretty point on my graph, and here's another pretty point on my graph. I want to count how many spaces down did we have to move. Look, 1, 2, 3, 4. We moved down 4 spaces, okay? Now, from here, how many spaces do I got to move to the right? 1, 2, 3. There's the slope of my line, right? We found it. All we had to do, y'all, was count, okay? Again, y'all, if it helps, do something like this, right? Like here's the point. We're going to move down 1, 2, 3, 4. We're going to move to the right 3. 1, 2, 3, right? You're just trying to count how many spaces, okay? So whatever you got to do to make that count, that's all you're going to do. Again, y'all, why was it negative? Because we had a fall. Why was it a fall? Because that line was going down, okay? Y'all, let's take a look at this one. Let's see if we can do the same thing here. Remember, y'all, my slope, either the rise or the fall over my run, okay? Y'all, first thing I want you to notice about this line, y'all, that line's going up, right? If I follow this line, we're going straight up, okay? Okay, so now let's see if we can do some counting here. I'm going to start at this pretty point right here that they labeled for me, and I want to get to that pretty point. And I'm going to figure out, okay, because it's a rise, y'all, my number on the top is going to be positive. I'm just going to count. 1, 2, 3, 4, 5. Boom, we went up 5. To the right, 1, 2, 5 over 2. And there's the slope of my line, right? Okay, excellent. Good, good, good. Yo, let me scroll down a little bit further. Okay. Yo, let's take a look at this line. Remember, y'all, we either call it the rise or the fall, right? Over the run. Y'all, first thing I notice about this line, that line does, at number one, it's horizontal, okay? So it's not going up and it's not going down. So did we rise? No. Did we fall? No. My top number, y'all, is 0. Then, how did I get from this point here to that point there? We didn't go up at all. So that's why that top number is 0. 1, 2, 3. 0 divided by 3, y'all, still 0. Okay. Y'all, now that's a horizontal line. Horizontal lines are always going to have a slope of 0. Okay. All right. Let's do another one here. Let's take a look at this line. Again, y'all, remember, either the rise or the fall over the run. Okay. All right, let's see. Whoa, that line, let's take a look at what's going on here. Y'all, from this point here to this point here, 1, 2, 3, 4. We went up 4. But, y'all, we did not run. We didn't go to the left. We didn't go to the right. So the bottom number here is 0. Now, y'all, we did this like on the first day of school, first day of class a few weeks ago, right? If we try to divide by 0, y'all, we could not do it. And that's when we said it was undefined. Y'all, this here is a vertical line, right? So, y'all, vertical lines always have an undefined slope, and horizontal lines, y'all, always got a slope of 0. Okay. All right, y'all, I'm going to keep scrolling down here. I'm going to skip this part, guys. We're going to do it again in a minute, okay? But I'm going to come down to this problem here because I put those same problems a little bit further down. Okay, so let's take a look here, y'all. It says find the slope of the line and write the slope as a rate of change. And it says this graph approximates the number of households that have personal computers in millions for year X. Okay, so y'all, let's take a look here. Let's see if we can figure something out. And look at this picture, y'all. Okay, so the first thing, y'all, I would say is, hey, you know what? That line's going up, okay? So y'all, since my line is going up, we're going to have a rise over the run, right? Okay, y'all, I want to figure out from this point here to this point here, how much did I go up by, right? Now, y'all, look, it's not exactly right on one of those lines, but I know that those numbers, y'all, I can think about this. That's my X1 and my Y1. I can think about that. That's my X2 and my Y2, okay? So look, let's just use that formula that we did, right? Y2 minus Y1, X2 minus X1, okay? Let's see, what's my number Y2? 87. Minus, what's my number Y1? 75. Okay. Y'all, my number X2, that looks like 2006. Minus 2002. Okay. So I'm going to take my calculator here. I want to figure out what's 87 minus 75, 12. Okay. From 2006 to 2002, y'all, that's 4. Y'all, we can actually divide that out. So 12 divided by 4, y'all, is going to give me 3. Okay. So y'all, I'm coming up with 3. Okay. But remember, I want you to think about something here, y'all. These numbers, the 75 and the 87, those are the number of households in millions. Okay. So let's kind of come back over here and let's see what's going on here. So, okay, look, y'all, the graph approximates the number of households that have personal computers in millions. Okay. So, y'all, this means that this is going up by 3 million every year. Okay. So, y'all, now I'm going to take a look and I'm going to see which one of these answer choices seems to best represent that. Okay, it says every year there should be 3 million more households with personal computers. That looks pretty good. So I'm going to circle part A. Okay, every 3 years there should be 1 million less. No, not every 3 years. We said 3 million households every year. So I know B is not a good option for me. Also, I'm going to scratch that guy out. Okay. Every year there should be 3 million less households. No, you know why not less, y'all? Because then they would be going down, and we didn't have that. And every 3 years, no, y'all, we said this was for every year. So look, that's not good either. Okay. So I don't want that part there either. Okay. Y'all, I'm going to scroll down a little bit further. Okay. And y'all, I'm going to come back to this part in a minute. What I'm going to do now, y'all, before I come back to this part, let's see, y'all, right here in our Blackboard page, there is, let's see. Okay, right here it says applications of linear equations. Y'all, I'm going to open this guy up. Okay. And y'all, what I want to do is I want to go ahead and go through this part, and then I'll come back and finish the rest of what we have. Okay. So y'all, let me do this. Let me see if I can print this guy here. Okay. And let's see. Come on, come on, come on. Here we go. Let's print it. Let's see. Here we go. And y'all, I'm going to send this to my OneNote. Okay, and let's see, it should be going over there. Here we go. I'm going to open up a new section. Boom. Okay, so y'all, again, just in case you're looking for it, y'all, it's right here where it says applications of linear equations. Okay, so y'all, what I have here are just some other type problems. And again, we're still sort of looking at the same idea. Okay, we're still looking at rates and all this kind of stuff. Y'all, I put this in here because, again, these are the types of questions that I remember seeing that when I took that TSI test myself, okay? So, y'all, if I look at this problem, it says the graph below shows data from a call assistance center. At what rate are calls being handled? Okay, so, y'all, if I kind of just look at this right here, these numbers are the number of calls that we've received. This is the time of day, okay? So, y'all, it looks like at 10 a.m., we had, 30 calls? And at 1 o'clock, we've had 90 calls? Okay. Yo, from 30 to 90, how many additional calls did we get? Well, we can do it like this. We can say 90 minus 30. That means we got 60 calls, right? In that time frame. Okay. Now, the next thing I want to figure out, how long did it take for me to get those 60 calls? Y'all look, from 10 to 11, that's 1 hour. From 11 to 12, that's 2 hours. From 12 to 1, that's 3 hours. Okay. So if we're getting 60 calls every 3 hours, wouldn't that make sense to say we're getting 20 calls every 1 hour? That's what rates really refer to, y'all. Okay. The most important thing here, and again, I know some of you guys have probably seen Y equals MX plus B, all that kind of stuff. Y'all, when I remember taking the test, these were the types of questions that they would ask. They would say, can you make a connection here? Okay. But this is really the slope of the line. That's really what we found. Okay. Y'all, let's try another one here. Let's do the same thing here. Let's see if we can figure out the rate. So y'all, the graph below shows the population of Cleveland. At what rate was the population changing? Y'all, first thing I noticed, this line is going down, okay? Y'all, since it's going down, that means that my population is decreasing, right? We had more people at one point, and then it's kind of gone down. So it's my slope, y'all, is going to be a negative number. Let's see if we can figure this out. Look, y'all, it looks like in the year 2000, we had 475,000 people, right? Okay. In the year 2010, it looks like we had 375,000 people. Okay. So let's do this, y'all. Let's say, how much did it go down by? From 475,000 to 375,000. Y'all, it went down by 100,000, right? Okay, since it went down by 100,000, y'all, I'm going to call that negative. Okay. How many years elapsed between 2000 and 2010? 10 years, right? So now, y'all, look, I'm going to do this. I'm going to say, what's 100,000? Oops, sorry. 100,000 divided by 10 is 10,000. So, y'all, that means that we were losing 10,000 people every year, right? It was going down. Why down? Because it's a negative 10,000. So on average, y'all, every year, 10,000 people left Cleveland, Ohio, right? Like, it's too cold over here from here, whatever it was, right? Okay, y'all, I'm going to scroll down a little bit further. And let's see if we can do this one talking about train travel. So it says, the following graph shows the data from a recent train ride from Denver to Kansas. At what rate did the train travel? Okay, so y'all, I'm looking here. I got a couple of nice points on my picture. So this point here and this point here. Y'all, it looks like at 3 o'clock. Y'all, if we're right here, right between 250 and 300, I would say we're at the 275 mark. Okay. Y'all, at 5 o'clock, we were exactly at the 450 mile mark, right? So I want to know, how many miles did we travel from here to here? Well, look, y'all, we can just take 450 minus 275, right? So 450 minus 275, y'all, we traveled 100 miles, right? Now, how much time passed from 3 to 5, y'all? Excuse me, that's 2 hours, right? So guys, if I divide 175 divided by 2, that means that that train is going 87.5 miles an hour, right? That's all we're doing here, right? So y'all, we're just kind of looking at the problems and we're trying to figure out, can we find some basic rates? And y'all, what we really did in this problem, we found the slope of a line, right? My slope was 87.5. Again, it was positive. Why? Number one, we're talking about speed, so it's not going to be negative. But number two, my line is going up, right? All right, guys, I'm going to scroll down a little bit more. Okay, so y'all, what I'm going to do here with these problems is, again, these are the types of questions that I saw, again, when I took the test, okay? So y'all, we're going to go back and do some of that Y equals MX plus B in regards to like regular lines. But for this part here, we're going to use some information to kind of model some data, okay? So look, y'all, it says the Bettis family is thinking about switching cell phone providers and is interested in a family plan. The plan has unlimited talk, text, and data for a fixed cost. And then the total cost is based on the number of phones for each family. Use the table below to answer the following questions. So look, y'all, if we have 2 phones, it's going to cost us $110 a month. If we have 4 phones, it's going to cost us $140 a month. Okay. We want to know how much are they charging me per line. So y'all, one thing I want to mention, a lot of times when we look at a problem like this, we might be tempted to say, well, look, what's 110 divided by 2? And that's 55. Okay. But then if we would have taken 140 and divided it by 4, I'm now getting 35. Okay, so I'm getting 2 different answers. So I don't necessarily want to do it that way, y'all. What I want to do is I want to figure out how much are they charging me for each additional phone. So let's think about it like this, y'all. From $110, it went up to $140, right? Doesn't that mean that they charged me an extra $30, right? Going from 2 phones to 4 phones. So they charge me $30 for the additional 2 phones. Doesn't that mean, y'all, that they are charging me $15 per line? Okay. They're charging me $15 per line. Okay. Now, y'all, what we want to know is what is the fixed cost? Meaning, what is the basic fee we're going to have to pay regardless of how many phones we have? Okay. So, y'all, we can do it like this. We can say, look, we're going to pay $110. Oops, 110, not 100. We're going to pay $110. Okay. And that 110, y'all, is going to be made up of 2 phones at $15 a phone plus whatever that fixed cost was going to be. Okay. So look, let's do it like this. That's 110 equals 2 times 15, y'all, that's 30 plus whatever my fixed cost is. So if I want to get rid of this 30, I'm going to minus 30. Okay. So look, let's do this. Let's say 110 minus 30, $80. There's my fixed cost. Okay. Now, y'all, what we want to do, we want to see if we can write an equation. Okay. So look, y'all, this is how we're going to write an equation. We're talking about our cost. How much are things going to cost? For every line, y'all, they charge me $15. I'm going to put with a P like for phones. Okay. In addition to those $15, y'all, we got to pay $80, right? So $15 for every phone, and then $80 is my fixed cost. But what I want to mention, y'all, what did we do in this first part? Hey, we found the slope of the line, right? We really said, look, from 110 to 140, we subtracted them. That's how we got $30. From 4 to 2, we subtracted them. That's how we got 2 phones. We divided it out. And then we said, look, if I'm paying $110 for 2 phones and each phone costs me $15, I'm going to take 110, I'm going to subtract my 30, I ended up with $80. That's what my fixed cost is. Okay. Y'all, just as a heads up, we could have used this part right here. We could have said, look, I have $140 for 4 phones, and it's 4 times 15, 60, subtract it off. I still would get 80. Okay. Y'all, but these are the types of problems, and I think it's really important to go through this, and then we'll come back and do some of the other stuff in a minute, y'all. All right, let's take a look at another one here. So look, y'all, Directly TV is a cable company that charges a fixed amount. Y'all like how creative I was with coming up with money. For a basic cable package and an additional fee, okay, for each premium channel. Okay, so again, let's see if we can figure something out here, y'all. So they charge me a basic cable package, and then they charge me a fee for every one of those premium channels that I get, okay? So look, y'all, right now we have 3 premium channels, and we're paying $85.99, okay? If we had 5 premium channels, we'd be paying $109.99. What I want to know is how much more would I be paying? So you look, y'all, I'm going to come back here, $109.99 minus $85.99. We'd be paying additional $24, right? From 3 channels to 5 channels, y'all, that went up by 2 channels. So y'all, that's telling me that they are charging me $12 per channel, right? Okay. Now, I want to know, what is the basic cable package? So y'all, I can figure this out a couple of ways. Suppose I decide I want to use this point right here, okay? I could figure this out by saying, look, I'm paying $109.99. I have 5 channels that I'm paying $12 for. And then what is my basic fee? Okay. So I could say, look, this is $109.99. 5 times 12 is 60 plus my basic fee. Okay. And then I could say, look, I just need to subtract 60, right? So y'all, I'm going to take 109 right here, 109.99 minus $60. Okay. That's $49.99. That's what my basic fee is, right? Okay. Y'all, again, part C, I'm sorry I didn't leave enough space here, but part C, y'all, says, can we write an equation that describes the cost of the cable bill? Yeah. Look, so my cable bill, you remember how much they were charging us per extra channel? $12, right? $12 for P, we're calling it the premium channels, plus my basic fee, y'all, of $49.99. Okay. Again, I think these types of problems here, y'all, are really important. Again, I saw a lot of these types of questions, y'all, in the test. So again, I'm just trying to get you guys to kind of think of the process on how I can like think this thing through here, okay? Y'all, I'm going to scroll down a little bit more, okay? And it says here, so cars typically depreciate at an annual rate. Use the table below to answer the following questions in regards to a 2007 Dodge Ram. Okay, so look, let's take a look, y'all. So cars depreciate, y'all. That means that they go down in value. Okay, so look, 3 years after we bought the truck, it was worth $16,200. 6 years after we bought the truck, y'all, it was worth $9,900. Okay, I want to know how much did it go down? Okay, so again, y'all, we agree it went down, went from 16,200. Sorry, oops. Sorry, let me move this way. Minus 9,900. Okay, y'all, it went down by $6,300. Okay, in a time frame from 3 years to 6 years in a 3-year difference. Okay, so look, y'all, if I take this number and I divide it by 3, that's telling me on average, y'all, my truck is losing value at $2,100 a year. Okay. Now, let's see if we can figure out part B. Part B says, how much was the vehicle worth when we first bought it? Okay. Y'all, when we first bought it, I want to go back to when we bought that truck on the first day. Okay. So look, y'all, if we were losing $2,100 a year, okay, and I want to figure out, well, I know what it was worth 3 years later. 3 years later, it was worth $16,200. But if I was losing this much every year, I want to go backwards. So y'all, I'm going to take 2,100. I'm going to multiply it by 3, 6,300, right? Y'all, if I were to add that number back to what it was worth 3 years later, right? I'm going backwards now. Then we could figure out how much the truck was worth when we first got it. 22,500. 22,500. Boom. There we go. Okay. Because we were going back, right? We said, look, let's take 6,200. Let's add 2,100. Let's add another 2,100. And let's add another 2,100. So we really added 6,300 back to it, right? And that's how much it was worth when we first got it. Okay. Now, y'all, for this last part here, part C, it says write the equation that describes the value. Okay, so how much was my truck worth? Okay, so look, y'all, every year we were losing $2,100. $2,100 times T, where T is the number of years. And when we first got it, y'all, it was worth 22,500, right? So this is how much it was originally worth. And every year we lose 2,100 because we're losing it, y'all. Happens to be a negative number. Okay. All right, guys, I'm going to scroll down a little bit further. And here it says, Mando has started an exercise and workout regimen so that he can lose weight. Use the table below to answer the following questions. Okay, so look, y'all, let's see if we can figure out a couple of things here. So remember, Mondo's losing weight, right? So we're going to figure out the rate because he's losing weight, y'all. It's going to be a negative number, okay? Let's do this. We know that in week 5, he was weighing 185.5 pounds. In week 10, he had gone down to 178 pounds. Let's figure out how much weight he lost, okay? So let me move this guy over here. So 185.5 minus 178. Y'all, he lost 7.5 pounds, right? Because he lost it, y'all, it's a negative number. Now, how long did it take him to lose that weight? From week 5 to week 10, y'all, that took him 5 weeks, right? So let's figure out how much he's losing each week. If I divide that by 5, y'all, he's losing weight, his rate, negative 1.5 pounds per week. Okay. Now, y'all, we want to figure out how much did he originally weigh? Okay, so how much did he weigh when we first started off? So, y'all, if you think about this for a second, right, and I come back this way, suppose I were to make another little thing right here. I want to know, what did he weigh in week 0 before he got started? Well, look, y'all, he was losing 1.5 pounds every week, right? And so we figured out what he weighed 5 weeks later. So we want to know how much did he weigh before. Couldn't we take that 1.5 and multiply it by 5 and add it back to that number? So look, y'all, if I multiply that by 5, 7.5 pounds. So y'all, I'm going to take his weight, 185. I'm going to add the 7.5 to it. So he originally started weighing, y'all, at 193 pounds, okay? So now, let's see if we can answer part C. Write an equation, okay, that describes Mondo's weight. Okay, M for Mondo. I was putting W for his weight. Go like this, M for Mondo. Okay, remember how much he originally weighed? He weighed 193 pounds, right? And every week he's losing, y'all, I'm putting a minus here because he's losing 1.5 pounds per week. Okay. All right, y'all, there's a few more problems here. These types of problems, y'all, I'm going to let you work on these. These are more like practice problems, y'all, and they're very similar to the ones that we just did, okay? They're very similar to the ones we just did, but I put those in there, again, for you to kind of practice on, okay? Y'all, let's do this. Look, it's 11:02. Let's take a 10-minute break. Let's come back at 11:13, y'all. And what I'll do is we will finish off where we left off over here, okay? So at 11:13, I will restart the session. We'll come back and we'll finish off what we got to do, okay? So let me go ahead and stop this, y'all. I'm going to go ahead and stop recording. Boom.